Hi everyone. In this short video I want to talk about compound inequalities. Now this is an example of a compound inequality. We have x sort of sandwiched between 2 and 4, and this actually is a combination of two inequalities. It means that on the one hand your x value is greater than or equal to 2, and at the same time your x value is less than or equal to 4. So a compound inequality is actually the intersection, because of that word and, of those two sets. Okay, so if I want to solve this compound inequality, one way I can solve it, going back to what it basically means, is I would have on the one hand 2x plus 3 is greater than or equal to negative 5, and at the same time 2x plus 3 is less than 9. So I'd solve each of those separately. So I'd go ahead and subtract 3 from both sides of the inequality, of both inequalities, and that would give me what, negative 8 over here is less than or equal to 2x, and again at the same time the 2x is going to be less than 6. And then when I solve this one, I have to divide both sides by 2. And when I solve this one, I'd again have to divide both sides by 2. So I get here that x is greater than or equal to negative 4, and at the same time x has to be less than 3. Alright, so if I think in terms of a number line where the x's are greater than or equal to negative 4, that would be these. Here's negative 4. The x's that are greater than or equal to that would be these values. And at the same time, x has to be less than 3. So here's my 3, and I want the x's less than that. So that would be these values. And I want the intersection of those, right? It has to be greater than or equal to 4 and less than or equal to 3. So the intersection is going to be this interval between minus 4 and 3. And notice that I could put these together. Again, I could say, well, that's x greater than or equal to negative 4, right? The and statement means that that it can also be written as this compound inequality. Well, this would have actually been easier, and this is probably the way you want to learn to do these. Instead of doing these separately, even though that's what it means, it'd be easier to write it simply 2x plus 3 greater than or equal to the negative 8, was it negative 8? Negative 5, and then less than 9. Let me get that correct. Okay, you notice if you compare with what we did above, I could solve this also by just trying to get the x all by himself in the middle right here, right? I'm sort of aiming, I know this is going to be my answer. So if I were to subtract 3 from all three parts, that would give me, negative 8 less than or equal to 2x less than 6, and then just divide all three parts by 2. And you see, if you compare that with what we did above, you'll see I'm going to get exactly the same thing, right? X is greater than or equal to negative 4 and less than 3. And that's my compound inequality. My x is sandwiched between minus 3 and 4, and I end up with, again, the same solution right there. Okay, now I also want to think about this graphically. If I come back up here and I were to graph y equals 2x plus 3. So if I look at y equals 2x plus 3, that's a line, right? The y-intercept's 3. The slope is 2, rise of 2, run of 1. Or a rise of negative 2, run of negative 1. Okay, so I can put all these dots on here and then hopefully draw a nice graph. My handy dandy graph maker here. Okay, so there's the graph of y equals 2x plus 3, and then let's also consider these other parts of the graph. Y equals negative 5. Well, if I look at y equals negative 5 and y equals 9, well, those have slope 0. This one has a y-intercept of -5. That's going to be down here, right? So that's just going to be a horizontal line that goes along here, and then y equals 9. That has a y-intercept of 9. Let's see, there's 3, 6, 9. I think that's up here. Okay, and again, the slope is 0. So those are horizontal lines. So let me go ahead and graph those. And if we think of this compound inequality graphically now, I'm really saying, okay, where is this blue line? Where is that sandwiched between the two red lines, between the -5 and the 9? You can see, well, it's right here is where it's between. You can see that, right? And again, I want the x's that correspond to that. So I want to look at the x's down here, and you can see that's going to correspond, right? This point of intersection is right down here. And I, in particular, want to know on this side, where is the 2x plus 3 greater than or equal to the -5? So that would correspond to these guys. In fact, let me go ahead and write it right on the x-axis. I can do that. Okay, so that would be these guys. This x here would correspond to the blue line equaling the red -5, and then any of these x's between here, right? If this x, notice the blue line is going to be between the two red lines all the way up to this point over here, right? Now over here I want to know where is the 2x plus 3 strictly less than the 9, so I don't want to include this point. I'll have any of these points between there are going to satisfy that inequality. And again, if you compare that with our answer, let me make it nice and big here so we can see that, right? Okay, so any of those values in there, any of these x values are going to make this blue line be between the two red lines. And if you look at that, what is that? Isn't that, oh, that's -4 up to 3, right? That is exactly the interval from -4 to 3. And notice that's the same thing that we got when we did it algebraically. Okay?